Hey guys, welcome to section 2.2, Finding Equations of Exponential Functions, part 2. We are actually going to find the equations of exponential functions this time. We're going to use the skills from part 1 of this lecture section to help us do this, but first we're going to do some kind of simpler examples. If you think back to 2.3, we talked about how exponential functions and linear functions are very similar. And similarly, there are some really easy ways to find exponential functions, just like there are really easy ways to find linear functions, and there are some more challenging ways. We're going to start off with the easy ways and build up. So the first way is, the kind of easiest way is, what if we're given a table of an exponential function? So what I want to do is I want to find the equation for the exponential function that is given in the table. Okay? So, we have this table, and I want to create the actual equation of this exponential function. So, what we have to remember is that the exponential function, the equation of an exponential function, looks like this. And so what we need to identify is what the a and b values are. Now, if we remember what these mean, if we think back to that 2.3 section, the b value is our rate at which we change. It's our growth rate, it's our decay rate, okay? Another word for that is base multiplier. And so that's the kind of idea we're going to use here. This is our base multiplier. It's the base of the exponential. It's what we multiply each time. The a value is our y-intercept. So remember, y-intercept is the point 0, comma, y, where that y is whatever our y-intercept is. In this case, it's 0, comma, a. So from this table, are we given the y-intercept? Absolutely. Right? The y-intercept is simply when x equals 0. So when x is 0, f of x is 4. So then what I know is that this function can be further written as 4 times b to the x. So now all that's left to do is identify what this b is. In other words, identify what do I multiply each time x goes up by 1. And to do that, it's really simple. We can take any number, any output, and divide it by our previous one. Now this is assuming we are given an exponential function. If we know this is an exponential function, I can make any one of these, and we do because we're told this is an exponential function. I can make any one of these outputs, and divide it by the previous one. I can't do that with 4 because we don't know the previous input. Okay, so I can do 108 divided by 36. Let's do it. Grab our trusty calculator because I know that's what you guys are all doing. 108 divided by 36. 3. What about 324 divided by 108? 3. What about 36 divided by 12? 3. 12 divided by 4? 3. So every single time x goes up by 1, we multiply that output by 3, which means b is 3. There we go, we're done. That's it. Now let's just say I gave you a table and I said find the equation of this if it's exponential or not, or determine if this is exponential. What I did there where I divided each one by its previous one and got 3 every time, that's a good way to check, right? Because for this to actually be an exponent, if just one thing changed, and this was 323, this is no longer an exponential function. This is all an exponential, but now I've changed it. So something's happened and it's not an exponential function anymore. If I keep that as the 324 that it was, it's now an exponential. So it's really easy. If we are given a table like this, it's super easy. Now, we've talked about the similarity between linear functions and exponential functions. And so what I'm going to do now is I'm going to give you 2 tables, not 3 tables, 2. And I want you to identify which one is exponential and which one is linear. And then I want you to find the equations of both. So I'm going to write these on the board, and I want you to pause the video once I get these up here. I'll let you know when to pause. And I want you to really actually work on this. Don't just let the video roll and wait 5 seconds and let me go over it. Try it yourselves, okay? So, all right. Go ahead, once I'm done talking, pause the video. I want you to find if these are linear or exponential, and then find the equation of each. Okay, pause the video and go, now. Come on, actually pause it, come on. Act like I'm here and looking at you. I'm waiting. All right, good job. Welcome back. Let's talk about this. Which one of these is a linear function, and which one of these is an exponential function? So what we have to do is we have to really understand what the difference is. Now, both of them grow at or change at a constant rate. The difference is that a linear function changes at a constant additive rate, something that's added every time. Whereas an exponential function changes at a constant multiplicative rate. So we have to kind of understand what we mean when we say change, the rate of change. If we look at this first function, f of x, we can see that when I go from 0 to 1, I went from -7 to -1. Now, to multiply to get that difference, I would have to multiply by 1/7. So -7 times 1/7 would give me -1. And we can just find that simply by saying -1 divided by -7 is 1/7. Or I'd add 6. Now to go from 1 to 2, if I multiply -1 by 1/7, this should be 1/7. It's not. So this already has been eliminated. That's not the exponential. So what do I add to get from -1 to 5? 6. Same as I added from -7 to -1. 5 plus 6 gives me 11, plus 6 gives me 17. This one here, f of x, this is our linear function. Now, what's the equation look like? Well, if you remember, from chapter 1, linear functions look like mx plus b, where m is our slope, our rate of change, and b is our y-intercept. Do we know the y-intercept just looking at this? Again, y-intercept is 0, y. So when x is 0, we get our y-intercept is -7. So I know this is going to be -7 for b. Do we know m? Do we know the rate of change, the slope of this? Every time x goes up by 1, what happens? We added 6. So we are increasing by 6 each time. And that's it, we're done. Now you may wonder why I don't have an f of x in front of this here. And it's simply because this acts as a kind of a continuation of a sentence. I'm saying that f of x is equal to mx plus b, which is equal to 6x minus 7. Now, if I were giving, say, a problem on the homework or anything like that, I would just write f of x equals 6x minus 7. That's perfectly fine. But for here, I wanted to kind of include those in-between steps. All right, so if this was linear, that must mean this is exponential, right? I would not give you an exponential one. That's correct. I'm not going to do that. We can also see that the change in numbers from over the same span from 0 to 4 changes a lot. Now, that doesn't mean it couldn't be linear, because maybe the rate of change is 400. Maybe I went down 400 every time. So what we have to look at is, okay, it changes a lot from here to here, but it only changes a little from here to here. So that's a pretty good sign that it is an exponential function. But we can also just simply check it. We take any one output, divide it by its previous. We should get the same thing for all of those. So let's do that. So let's grab our calculator, and let's do 5 divided by 20. If I can type things, there we go. And we get 0.25. Or if we use math, and then we just want to choose option number 1 here, we hit enter, 1/4. And if we do that with all of those, 20 divided by 80, 80 divided by 320, 320 divided by 1280. Oh, there. 320 divided by 1280. We get 0.25 every time. This one that's not 0.25 is because I did 20 divided by 1280, not 320. So this is absolutely our exponential. So g of x is our exponential, and an exponential function looks like g of x equals a times b to the x. So a is our y-intercept. So we have to know, do we know our y-intercept? 1280. B is our base multiplier, that multiplicative rate of change. So what do I multiply every time x goes up by 1 to get to the next output? Well, to find that, we just simply take any output divided by its previous, which we already did, and that was 0.25, or 1/4. Now, on the test, I'm not going to mark you off whether you say 0.25 or 1/4, unless I specifically say to use fractions, or I specifically say to use decimals. So make sure to pay attention and read the questions so you get it right. That's it. That was pretty easy, right? All right. Let's do something a little more fun. I want to now find the exponential function that passes through the points. Let's get my points right. 0, 5. And 4, 4, 5. This is a very similar question that we got with the linear function. With the linear function, we would find our slope, and then we'd plug one of the points in and get our rate of get our y-intercept. And actually, we wouldn't even need to do that in this problem here because we're given our y-intercept. Isn't that really nice? So if this were a linear function and we're given the y-intercept, we plug that in, then we plug in our other point, and we solve for our slope. Same exact thing is going to be done here. We know what our y-intercept is. So I want to find the exponential function. So that means I'm looking for something that looks like this. I know that when x is 0, y is 5, which means that my y-intercept is 5. So I know that this equation is going to be 5 times some b to the x. Now how do I find that b? Well, I use this point here. Because what I have here is essentially I have an f of x equals 5 times b to the x. So I have the output equals 5 times some base raised to the input. If I know an input and output, I can create an equation. That's what we're going to do. So when the output is 405, that means that the input had to have been 4. Okay? So when the output's 4, when the input's 4, we get an output 405. This gives us an equation. This is an exponential equation like we solved in part 1. There's nothing being added on or subtracted, so we don't have to worry about that. We just have to divide by 5. And I get b to the 4th equals, so 405 divided by 5 is 81. I have a b to the n equals k. Now, you may feel uncomfortable because this is flipped backwards, and if that's the case, feel free to write one more line down here that says b to the 4th equals 81. But remember, when we have this, we have to look to see which of the 3 cases are we in. Is n odd, or is it even? And if it's even, is k positive or negative? So here n is even, so we have to worry about k. K here is positive, so that tells me the solution to this equation is b is equal to plus or minus the 4th root of 81. Now I know you guys are very intelligent people and can use your calculator to find the 4th root of 81. I'm going to help you out, make this a little shorter. It's 3. So the solution to this equation is that b equals plus or minus 3. Now, what does that tell me for my function? I mean, I can't have two things, right? There's two. But what do I know? Think back to 2.3. That's right. There were restrictions on this, right? A couldn't be 0 because then it's constant. B can't be 1 because then it's constant. And B had to be greater than 0. That's right. If B has to be greater than 0, which means the negative version cannot be my B value for my function. Now, it is a solution to this equation, but it's just not what I want to use here. So that means my function is 5 times 3 to the x. If you ever have this happen, and you're creating the function, not solving the equation, but creating a function, you'll always use the positive value because b cannot be negative. There we go. We got it. All right, you guys. Let's do one more. I shouldn't have erased all that, but oh well. We're going to do the exact same thing. Okay? So, find the exponential function that passes through the point zero to 100 and 886. Again, notice we're given the y-intercept. For this class, I'm almost always going to give you the y-intercept. If I don't give you the y-intercept, it's because I'm giving you a table or something that's really, really easy to figure out that you would just kind of, okay, I've got all these values. If I multiply each time, I just divide once and I get there. But even that I probably won't do. So if I give you a word problem and you go through and get points, you don't have a y-intercept, you probably created your points wrong. Okay? We'll put that as a flat base. I will not give you a problem to do this without giving you the y-intercept. Unless I specifically say, I do not give you the y-intercept here. Just to make things very clear. So again, let's do g this time. So g of x is a times b to the x. A is our y-intercept. That's 200. So we get 200 times b to the x. This is exactly the same. We just do the exact same thing. Once I have that y-intercept, I just need to solve for b. I can use this point to create an equation. And that equation becomes 86 is 200 times b to the 8th. Now you may be looking at this going like, oh my gosh, there's an 8th and like 200s and 86, but let's just relax. Breathe out the stress and let our calculators help us. We do the same thing we did last time. I am going to need to get this b by itself, so I divide by 200. B to the 8th equals, so we are going to do 86 divided by 200. We get 0.43, okay? Now, if I convert that to a fraction, it's 43 over 100. Honestly, either one is fine to keep. I will just keep it as 0.43. If this is a number that when you have it as a decimal, it goes on forever, always write that as a decimal, or as a fraction, sorry. Always write it as a fraction unless that decimal terminates. So this one was just 0.43. There's nothing more to it. So writing it as 0.43 is perfectly fine. But if this is 0.43333333 forever, you need to write that as the fraction. That way you capture the exact value. All right. I have a b to the n equals k. We need to follow our steps. Which of the three cases are we in? N is even, so we're not in the first case. K is positive, so that's where we're at. So that means that, very simply, b is plus or minus the 8th root of 0.43. So again, to do 8th root, you can just take 0.43 and raise it to the 1/8 power. Like that. Or we can type 8, math, option number 5. and 0.43. And what we get is 0.8998778,395. If we round that to 3 decimal places, 0.8998, so the 8 makes the 9 go up to a 0, which makes the 9 go up. So this is just approximately plus or minus 0.9. Now, same exact thing as with the last problem. The solution to this equation is approximately plus or minus 0.9. But we don't want both in here. B can't be negative. So 200, 0.9 to the x. Now, how can I check this? What can I do? Well, we could just check. The only point we know is on here besides this, which is obviously going to come here, because if anything to the 0 is 1 times 200 is 200. So we can check this point. So I have 200 times 0.9 to the 8th. So just like that. Okay? And so that would just be using this equation here with 8 as my input. So I hit enter. Not negative. Working a calculator backwards is less easy than I thought. Okay. There we go. And I hit enter. And I get 86.09. And we're like, wait, it said 8 is 86. But is that approximately 86? Yeah, that's approximately 86. And that makes sense because we used our b value as an approximate to 0.9. Now, if we used our b value being exactly the 8th root of 0.43, when we put 8 in there, we should get exactly 86. But because we used an approximate value, when we tested it, we got approximately what we needed. And that's exactly how that works. All right, you guys. You guys are all tooled up now to solve exponential equations as well as to find an exponential function through 2 points or from a table. I'll see you guys next time.